Hello, I J. Vijay Chandra welcomes you to Wits Connect. Today I am going to discuss regarding assembly language. Assembly language is a low level language and it can interact with machine language. So let's see the structure, how it is associated with other languages. The first is the application program. The application program and in between the hardware, the application program is the first one, and from application program hardware is the computer system. From application program and hardware in between we will find this assembly language. It is a low level language. What is the assembly language? Assembly language is a low level language. It is machine specific. It is a machine specific language. So this assembly language will be interacted with the machine language as well as high level language. That means it will act as a bridge between the machine language and a high level language. The hardware, computer hardware will be controlled with the microprogram controllers. So these microprogram controllers are linked with the machine language, and this machine language cannot be understood by us since machine language is with zeros and ones. The code, the computer can understand only two numbers, that is binary numbers, that is 0 and 1s. The machine language will understand only two numbers, that is 0 and 1. So this machine language, to understand this machine language, we take a help of a assembly language, something like a translator. So assembly language will be in between the machine language and a high level language, and by using a assembly language we can code a small code which can be understood by the hardware. Hardware related programs can be done, that is microprogram controller related concepts can be done by using an assembly language. So this is the basic, this is the total overall structure of a assembly language. So in this structure we will find in between, in middle the assembly language, the down will be the hardware, the top it will be the application program, that means MS Word, MS Access, whatever the application application program. Nowadays we are calling it as apps. In the mobiles we are calling it as apps. So to create an application program, what we need an high level language. For the high level language to the machine language, in between the bridge is the assembly language, and whereas assembly language is a machine specific low level language, whereas high level language is a machine independent language. So this is overall an idea regarding a assembly language, where assembly language is placed in between this is the software and this is the hardware. In between software and hardware the assembly language will be in between. So example of machine language. The machine language, already I said that the machine language will be with the zeros and ones. Here the program fragment, this is the total machine language program fragment which explains z equal to x plus y. But to understand it, it's very difficult to understand the machine language. What it is there we can't understand. So we take the help of the assembly language. So now the assembly language and machine language, assembly language and the machine language, in between the assembly language and the machine language, the language here, the machine language is to a processor and executed directly by hardware. So machine language will be understood by the hardware and it is directly executed by the hardware, whereas the assembly language will have the symbolic names to present the operations, registers and memory locations. So in the instruction formats we already discussed that some registers will be there, memory locations will be there, and the operations we can perform by using opcodes. Okay, so we can move we can add, we can subtract. All these operations can be done by the instruction formats. Instruction formats, we are going to do some operations. So this is about the use of the assembly language. By using the symbolic names, we can do the operations which is related to the registers and the memory locations. Okay, it is slightly a higher level language, whereas a machine language will have the operations which can be used, whereas the assembly machine language will have the instruction control by using only the binary code. The binary code is 1 and 0. 1 and 0 are the binary codes. Okay, binary codes only 2 digits, that is zeros, and another is the 1. Whereas machine language, assembly language, we are going to use some codes like move, add, mov move, add add, sub for subtraction, mul mul. So all these can be used. Okay, readability of the instructions better than the machine language. Machine language we can't understand. You can see in previous slide. This means that z equal to x plus y. But can we understand it? We can't understand. So whereas in assembly language it will be like this: add x y. Okay, so again the x value, z value equal to assign, we will assign to the whatever we added to whatever we added the y value to the x, that value will be assigned to the z, then the output we are going to get the output. That is very simple, we can understand. Readability is possible in the assembly language. In assembly language we can read, whereas in the machine language we can't read. So this is the difference. The readability is possible in the assembly language, whereas in the machine language readability is not possible. One-to-one correspondence with the machine language instructions, we can understand each step in the correspondence with the each step with the machine language instructions by the assembly language. So to write the code in machine language is very difficult, so we will take the help of the assembly language as a translator. Okay, whatever we written in the assembly language, that will be understood by the computer, but in between there will be a machine language. Whatever we written, it will be converted to the machine language, and then it will be understood by the machine language. So compiler and assembler. In your first session, in your previous years, you learned C language. Okay, when you learned the C language, you use the turbo C compiler. So after writing the code, you are going to press Alt C, that is you are going to compile the program. Once the compilation process is successful, then you are going to execute the program. That means compilation is checking the errors and recorrecting them. That is the process of compiler. And here assembler is different from the compiler. So machine language is an assembler. So assembly language is a compiler. It will link between the machine language as well as the high level language. So it acts as a compiler as well as the assembler. Next, assembler. Software tools are needed for editing, assembling, linking, debugging in assembly language programs. So you should able to write, that means you in Notepad or any platform, that means where you can type the program, then you can link with the we can assemble with the or link with the execution part, and we can get the results. That is one process. So an assembler is a program that converts source code program written in assembly language into the object files in machine language. What an assembler will do? The assembler is a program. It is a program which converts the source code, whatever the code is written in the assembly language, into the object files in the machine language. So this is the main relation between the assembly language and the machine language. So whatever you written the source code which is written by the written, and it will be by using an assembler it will be converted to the machine language. Ante that means without an assembler you can't execute a assembly language program. So what are the assemblers available in the market that we will see? One is the TASM, TASAM, that means turbo assembler. It is from the company known as Borland. And then comes to the NASM, net wide assembler with Windows and Linux. So by using it can be used in both operating systems such as Windows as well as Linux. Then comes to the GNU assembler. It is a distributed by Free Software Foundation. So these are the three assemblers. What are they? TASM, T for turbo, ASM for assembler. TASM, TASM, okay, TASM, NASM, netwide assembler, which can be used for Windows as well as the Linux, and GNU assembler is the special software which can be freely downloaded, free software. Okay, so these are the three softwares. When you are going to do the practical session in the assembly language programming, assembly language practical session, you have to download or you can use any of these three softwares. Next comes to the mnemonics, M is silent, mnemonics. So assembly language, in assembly language mnemonics are used to specify an opcode that represent a complete and operational machine language instruction. This is later translated by the assembler to generate the opcode. For example, the mnemonics move is used, MOV is used in assembly language for copying and moving data from between the registers and memory locations. So we taken an example of MOE. MOE used for the copying. MOE is used for copying as well as for the moving of the data between the registers and memory. So in the registers as well as the memory, this MOV mnemonic will be used. So this is a sample example regarding the assembly language command. Then comes to the instructions and machine language. So already we did about the instruction set. Okay, the machine language you will understand only in the binary format, that is 0 or 1. Instead of 0 or 1, it can't understand any other words or any other letters in the computer. So machine language will understand only the binary format and computer deals with only the binary data. Hence the instruction should be in the binary format. So each command of a program is called an instruction. So every command which we are going to give it to within a program is called an instruction, and it can be, we can instruct the computer what to do. Because of the instructions only computer is working, that means accepting our commands or instructions. Next comes to the set of all instructions in binary form makes up a computer machine language. These instructions are called as instruction sets. So all the instructions which are in the which are used to operate, or the set of instructions comes under the instruction set. Next comes to the instruction fields. So address instruction fields. In the topic of addressing instruction formats, we already discussed about what is opcode and what is operands. So the same thing here. To give an instruction to a computer, we should know about the instruction fields. What are the instruction fields? There are majorly two basic instruction fields are there. One is the opcode. Opcode is the first instruction field, and another is the operand. Opcode and operand are the two basic instruction fields. Based on it only we are going to give the instructions, and we are going to use the registers or memory allocations to fit these instructions. So opcode field, which stands for operation code, and it specifies the particular operation that to be performed. What to be performed, that will be understood by using an opcode. By using opcode only, it will perform the particular operation, and this operation can be performed by using only the opcode. Next comes to the operands. Operands is a specific field or the source to get the source and destination operands to the operation specified by the opcode. Opcode లో మనం ఏదైతే ఆపరేషన్ ఇస్తామో ఆ ఆపరేషన్ కి సోర్స్ కానీ డెస్టినేషన్ కానీ ఉండాలంటే we need the operands. Okay, source and destinations of operands can be construct the memory or one of the general registers. So this is about the opcode and operands. Take an example. Assembly language instructions to build a two pieces, add r1 comma r3 comma 3. So add అనేది opcode what ALU operation will perform is the opcode, that is add. The operands are where we are going to do that addition is the r1 and r2. Those are the operands where get the data and put the results. We are going to get the data and we are going to put the results. That means we are going to give source as well as the destination. Source and destination are given by the operands, whereas opcode will give the operation code. Next comes to the types of opcodes. The types of opcodes that was supposed or supported by the assembly language are arithmetic and logical, memory, load and store, control transfer, and complex. These are the different types of opcodes which are possible. The first one is arithmetic or add, sub, mul. So addition, subtraction, multiplication we are going to use by using the arithmetic opcode known as the add, sub, mul, and or is the logical. CMP is also for the comparison. So next is memory, load or store, LD for loading and ST for storing. Then control transfer, you are going to transfer the control, that means we can go give the instructions to transfer the data or transfer the things. So steps, so for that we are going to use two controls, one is JMP for jumping and another is BNE. Then comes complex, that is moves. We can move the data or that is nothing but copying the data. Next, operands. So each operand takes from a particular addressing mode. In particular addressing mode, each operand will be taken. Example, register, add r1 comma r2 comma r3. Immediate is add r1 comma r2 comma 10. Then indirect, so these are the type of operands. Already we discussed addressing modes: register addressing mode, indirect addressing mode, immediate addressing mode. So these we are implementing here, we are going to check here. Next comes to the translation languages, that is the assembly language which we are going to use here. In English, D is assigned the sum of A times plus 10. It is a general English. Then it is when we are giving it in assembly language, D equal to A into B plus 10, A asterisk B plus 10. That in assembly language how we are going to write is move EXEA A. So A value will be moved into this particular register. Then mul B, you are going to multiply with the whatever is moved. Then add EXA, there is memory space with 10. Then move D to EX, that means whatever value is in EX it will be moved to D, so that we will get the output. And the same thing when it is in the machine language, it will be like this. It is difficult to understand what it is. Then comes to why to learn assembly language. What is the use of assembly language, where it will be used, what are the applications of assembly language, why we have to learn. See here, for electronics or any chip to be activated, or let's take an example, any hardware device needs drivers. Without drivers we cannot we cannot use any hardware device. So what is a driver? Driver is a program which interlink with the hardware device and a software application. So in between there will be a driver. Drivers are the programs. So to design such drivers we need an assembly language. Very large scale integrated circuits and all the related small circuits to large scale integrated circuits, all the circuits will be understood by the general programming system if there is an assembly language program in between them. Okay, so that is the major importance of the assembly language. Assembly language is the accessibility to system hardware. It will access to the system hardware. Assembly language is useful for implementing system software. System software will be implemented by using the assembly language. Also useful for small embedded system applications. It will be also used for the embedded applications. Then space and time efficiency can be done. That means whatever the language or whatever the software, we will measure the performance of the particular code or particular software. The performance of the program will be measured based on the two things, that is space complexity and the time complexity. So these two are the major performance measures used to learn the requirement of the assembly language. So you can write a compact code by using the assembly language which facilitates us to occupy less space and with a high speed, that is the space and time efficiency. Writing an assembly program gives the computer designer the need deep understanding to instruct a set and how to design one. To be able to write the compilers, HLLS, high level languages, we need to expert with the machine language. Assembly language programs this experience. So in between the assembly machine language and high level language, we need a programming language, that is the assembly language. Now it's a time to know about the advantages of the assembly language. What are the different advantages of assembly language? It shows how the program interface with the processor, how the processor is there. It will give you the appearance, and it even operates the system, and BIOS also will be operated by using the assembly language programs only. That means when you start a computer can start chesinappudu, the first thing is in the RAM or in the BIOS, it will execute some programs. Then only the hardware will start. Hardware section, the link between the hardware as well as the software will be interlinked by firmware. A firmware is another term which will interlink the hardware and software. So to interlink between these two, we will have a program interface. So this program interface will only be through BIOS. That means first the processor will start executing. Once the processor start executes, then BIOS will start execute. Then it will enter into the operating system. When computer start jayegane, you will get some numbers. In old computers you can observe very clearly. You will get some numbers. That is, it is making the processor ready, and the RAM programmable read-only memory chips will activate first, and then it will link to the processor, and from processor the BIOS, that means time settings, date settings and system settings, all will be executed. Then password program will be executed. Then only it will enter into the operating system. So these are the different steps when you start any hardware device. It not only the computer, if it is a mobile also, first it will go to the processor, and from processor to the BIOS, and BIOS to the operating system of the mobile. Operating system of the mobile means the software of the mobile. That means to link with the hardware as well as the software, there is another term known as the firmware. Firmware will be in between, and these firmware related programs can be done by using the assembly language. So assembly language is the concept which will do the program interfaces. Based on the program interfaces, it will be executed. Now next thing is the how data is represented and stored in the memory and on external devices can be easily understood by using an assembly language, whereas by using any machine language it is not even possible to understand what is happening there. Next comes to it classifies how the processor access and execute instructions, how the processor will access and how the program will execute instructions. That also will be understood by using the assembly language, and how the instructions access the processed data. These all steps will be done by using an assembly language. These are the and even it clarifies the program access to the external devices. So whatever not only the device, that means the electronic device, external devices also interlinked will be done by the programmings which are built by assembly language programming. So these are the major advantages of the assembly language programming. Next comes to the applications of assembly language, where this assembly language will be used. What are the applications of assembly language? Assembly language is used when speed and reliability of overriding factor is small footprint real-time operating system. So assembly language is meant for the real-time operating system. It is used to write the code for the machine level languages, and it is also used to access the registers and memory allocations, and it will, which is not provided by any high level languages, will not give such a fascinated facility. So whereas the assembly language will give a facility to communicate with the hardware devices. So it is a main application. The assembly language is an application where it will direct the hardware manipulation, that is device drivers. So every device driver is nothing but a assembly language program which will link the software to the hardware. Then comes to the assembly language is directly correlates with the machine instructions, and it can only the machine instructions can be written by binary or hexa code, but no one can understand the binary code or hexa code. So it's very difficult to understand a binary and hexa code. Starting I shown you how the binary code will be there. So simple for write z equal to x plus y, we need all these things. So it is difficult to understand. So what we use is the assembly language. In assembly language it's very easy, add r1 comma r2. So whatever the register data stored in the register r3, it will be stored in the r1. So the output we are going to get in the r1. So these are the major advantages and the applications of the assembly language. By this I am enclosing this session. In next session we are going to do how to download the assembly language software, that is assembly language software are mainly three. One is the NASM, assembly language software are mainly three: NASM, TASM and NASM, that is net wide assembler, which can be operated in Windows and Linux. Then comes to the TASM, turbo assembler given from the Borland, and next is the GNU assembler. So any one of them we will take and we will do the small programs, that is the practical session of the assembly language. By this I am enclosing today's session. Thank you very much.